Hey, my name's Keith Weber. I'm the GIS director at Idaho State University. And I'd like to welcome you all to this workshop webinar. This is the first in a series that we're planning on doing in support of and working with the Idaho LIDAR Consortium at Boise State University and my colleague Nancy Glenn over there. This one is kind of I guess it's kind of basic, but I think it's also very necessary. And what we're going to talk about today is how to use Globus, large file transfer, to download and acquire LIDAR data. So today what we're going to do is go through this itinerary, very similar to the one that was emailed out to you in PDF format, a brief welcome and introductions. We're going to talk a little bit about LIDAR data, the challenges with LIDAR data, and then we're going to talk about how to use Globus Online to tackle this big data problem, open the floor up for questions and answer, and then we'll wrap it up just before noon today. Welcome and introductions again. My name is Keith Weber. I'll be your facilitator or instructor for this webinar. I'd like to acknowledge again the Idaho LIDAR Consortium. There's their website if you're not familiar with it. I encourage you to visit that website. It's kind of the, if you want to call it, the one-stop shop to kind of get you started on acquiring LIDAR data in Idaho. A chance also there to coordinate LIDAR acquisitions across the state, learn some things about LIDAR, and so on and so forth. I'd also like to acknowledge support from FEMA. FEMA made funding support available so that we could do this workshop and other workshops that we have coming up, webinar-based, and some in-person hands-on workshops we have coming up later this year. And I'd also like to acknowledge USGS and their specifically their 3D program, the 3D elevation program. They have also funded quite a bit of the LIDAR data acquisitions in Idaho. And essentially, while not 100% true, most of the great majority of LIDAR acquisitions in the state of Idaho have been funded either by USGS or FEMA. Let's talk just a little bit about LIDAR. I don't know how much people know about LIDAR that are attending this, and we're not going to get into all the nuts and bolts about LIDAR here. We're going to focus more on how to acquire LIDAR data, I guess, whether you know how it works or not. But just real briefly, LIDAR is an acronym. It's light detection and ranging. That's normally what that acronym stands for. And in this webinar, we're going to focus on a specific type of LIDAR called airborne LIDAR, which is sort of the acquisition like you're seeing in this slide's graphic, with an aircraft passing overhead and acquiring the elevation data and ancillary information for the ground immediately beneath it. We're not going to be talking about terrestrial LIDAR, although that is another type of LIDAR that excuse me, is available. So for every laser pulse, so if you look back or remember that little graphic we looked at a moment ago, what's happening is that that aircraft is emitting laser pulses. Each laser pulse is a point. We can think of it, and it is, a point in geographic information systems, in GIS. That point is attributed with a minimum of the X location, the Y location, those coordinates, the Z of that point, along with T, time, as well as roll, pitch, yaw of the aircraft. Now, each return represents yet another point. So there's a laser pulse that's emitted, and then there are returns that come back. And that's really what we're really interested in when we're working with LIDAR data. That return point information is attributed with a minimum of X, Y, Z, and T as well as the intensity of the recorded return. These data then become an LAS file. So each return or record in the attribute table, an LAS file, occupies 20 bytes. And on the side here, you see a table representing all of that information that's recorded as part of an LAS file, recorded as part of the return, and then stored in this format. Now, this format follows a standard put together by the American Society for Photogrammetry and Remote Sensing, ASPRS. Let's dig into this just a little bit more. High quality LIDAR data, let's say QL1 data, that actually on QL1 is 8 pulses per square meter, and we can have, any number of returns, 8 returns per pulse, whatever. So now we have an awful lot of information just per square meter, an awful lot of data that's starting to come back. So for instance, if we have a 100 square kilometer area, let's say it's about 25,000 acres, that's 100 square kilometers roughly. That is 100 million square meters. So now we have 100 million pulses, okay, just one pulse per square meter. That is 800 million returns on QL1, 8 pulses per square meter. That all by itself is 15 gigabytes of data. Now, as a project, you may be looking at a project that covers a county or a city, a community in Idaho. Those projects are normally tiled, so they're broken up into smaller chunks so that the project becomes more manageable simply because of its size. That 100 square kilometer area could be only one tile in your project. For example, let's say Bannock County, Idaho is let's say it's a LIDAR project that covers 3,000 square kilometers. So then Bannock County would require 30 of these tiles. That's 450 gigabytes of raw data, or approximately half a terabyte of raw data. Now that project can easily grow, as you can imagine, to over 1 terabyte in size. We have that, if you want to call it the raw LAS files. We'll have vector tile polygons, oftentimes stored in shapefile format. We'll have vector break lines, line data, also normally delivered in a shapefile format. We'll have the metadata documentation stored in XML format, reports oftentimes normally stored in PDF, plus the derived raster products such as elevation, highest hit, intensity layers, and so on and so forth. Sometimes we'll get several elevation layers. One might be a bare earth model, one might be a bare earth hydro-enforced layer, another one bare earth hydro-flattened layer. So you can imagine, with all this raw data, all of the products that are derived from it, we are talking about truly big data. The tip of the iceberg is maybe what you see, the elevation stuff that you're working with, but the LAS files and all the, if you want to call it the raw stuff behind the scenes, makes up what's beneath that surface. And the LAS files are far larger than the raster TIFF files that we end up dealing with as finished products oftentimes. So, downloading LIDAR data. If we use traditional, and we tested this out quite a few years ago when we first started working on this project together, ISU's GIS Center and Boise State University's Idaho LIDAR Consortium, using traditional HTTP downloads over what we oftentimes call the commodity internet. Those download tools usually, very, very frequently, resulted in failures. The browser that you're trying to download with would time out, and that's kind of built in into Windows. The files are simply too big, and well, we could say Windows is impatient. Using FTP access, however, would probably work to allow the file to move from our servers to your workstation. However, that also poses some security risks. Idaho State University and other organizations more or less disapprove of general or standard FTP, so we really don't have that as an option to use it to move those files. Instead, what we are using is Globus. Now, Globus really provides an ideal solution. It has a very nice interface, as we're going to see. Another huge benefit of Globus is, let's say, you are trying to download a half terabyte file. This is going to be a zip file. Let's say you're trying to download that half terabyte file, and at about 450 gigabytes into it, something happens. Your network disconnects, something happens, and the download fails. Well, the wonderful thing about Globus is you can resume that download. You don't have to start all over. Just tell Globus once everything is resolved, network connections, whatever, just tell it to resume, and you'll then pick up at 450 gigs and complete it through the full half terabyte, and your download is complete. Now, Globus isn't necessarily going to move that data across to you in an instant. It's fast. Yeah, it's about the fastest thing that I've seen, but there really is just about no way to move this large of data instantly. It's just not going to happen. So let's walk through a LIDAR download workflow. The first thing that we want to do is we want to find the data that we want to download. And what I would recommend is that you visit the Idaho LIDAR Consortium and use its search tools. So I went over to ILC, clicked on their data, and looked at the data map. And this is an interactive map, so you can work with it, zoom in, zoom out, look for data. So what I've done is I've zoomed in to southeastern Idaho, down in the Bear Lake area, and I found a LIDAR acquisition for the Bear Lake region. And we see that there's a couple of links here. I'll click on that link, which then opens up this second page, Bear Lake 2017. We'll see that it is indeed acquired as airborne LIDAR. It's 319 square kilometers in size. There's the date range when that data was acquired, point density, 8 pulses per square meter, so it's QL1 data collected by Quantum Spatial out of Corvallis, Oregon. There is also, if all you want to do to start with, instead of downloading all the data, you can download the report. That's that PDF report. And then once you decide that, yes, this is the data I want, this is exactly what I'm looking for, then you're going to use Globus online services to acquire that data. Now, I should also make a point that to differentiate really what is Globus. Globus is a service that's available that we're taking advantage of. Globus doesn't store any of the data. Globus is just that transfer service. All the data is stored on ISU GIS Center servers, and we're simply utilizing Globus to enable that transfer for you. So now what you're going to do is you're going to end up visiting the GIS Center's website, and specifically our spatial data library. There's a link to it, so you can jump to it automatically. You'll see that all the LIDAR data is on the ILC website is referencing this server. So we end up at that page. We'll then click on LIDAR to jump into that specific page. And what we've done to try to make this data just a little bit more useful, or maybe not even, I shouldn't say useful, but to make it a little bit easier to find, is, you know, as I mentioned earlier, these data sit on a number of different servers. And the data by default is categorized by its type. Now, we said earlier, okay, this LAS file represents raw LIDAR data. So there is a folder on our server when you start jumping into it, and we'll see it here in just a little bit, that's called raw. And that's the place to go to if you're looking for the LAS files, that ancillary vector data, the metadata, and the reports. If you're not interested in the LAS files, remember, these are the really big files. If you're not interested in those, you may be interested in the processed data. That's the raster data in TIFF file format. This is the bare earth models, the intensity images, the highest hit, those sort of things, as well as the metadata and reports. Most people want the metadata and reports no matter where they go, so we've kind of replicated that data or duplicated that data in both the raw and the processed folders, subfolders. So you don't have to go hunting around to get the reports and so on and so forth. And then all the data is further categorized spatially. And as you can see in this graphic here, the dark blue area is the spatial region we simply call Eastern. The purple we call Western Idaho, and all the green is in Northern Idaho. So pretty easy to figure out, okay, my Bear Lake is right over here. I'm gonna definitely be looking at the Eastern Idaho subdivision once I jump into either the raw or processed folders. Okay, so let's say I finally found my data. I know that you guys have it. The GIS Center has it. ILC points you to the GIS Center. Now, how in the world do I download this stuff? Okay, let's step right through this. We're going to utilize Globus to tackle this big data. Now, there's a first time or one-time setup whenever you're using Globus, and literally it's one-time setup. You're going to visit the Globus website there at globus.org and create a free account. They offer free accounts. You don't have to pay for a subscription to start utilizing Globus. Part of that initial free account or account setup is where you're going to download and install Globus Connect Personal. There's the direct link to it if you just want to jump right to that. This creates essentially a receiving endpoint on your computer and establishes a secure connection between your computer and whatever you connect to, like, for instance, the LIDAR server here at the GIS Center. Now, when you're creating that account, one of the things that I recommend that you do is to document the name that you're giving to your Globus Personal Connect endpoint. You can create numerous endpoints and give them different names if you want to. I don't do that. I just have one name for my workstation. But you have to recall what that is because you're going to be utilizing that name later on when you start using Globus. And once you've used your Globus Personal Connect endpoint once, then Globus will remember it and you'll be able to jump back to it pretty easily. But the first connect, the first time that you do this, it's pretty important just to jot that thing down, copy and paste it somewhere, whatever, so you can get to it later on. And that is that one-time setup. Once it's complete, you're going to notice that you'll have a Globus Connect Personal running on your computer. And that's going to appear just in that little taskbar over by your clock. You'll see the Globus icon. That's this G right over here that I'm pointing at. And that, if you click on it, it will tell you, when I clicked on it, it told me I am connected. My endpoint is named Pyrenees Desktop. That's the name of my computer, and it's my desktop. Okay, that's cool. So we know that it's running. Now we want to log into Globus Online. And if you're going to do this all at one time, click, 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 you will still be logged into Globus. So you won't have to log in again. But if you set it up one time, maybe do a download, maybe a week later, you need to do another download, okay, then you're going to need to just double check that it's running, that one-time setup, then log in to Globus. From the Globus file manager, now you're logged in, you're going to click this collection text box right here, collection text box from this Globus landing page when you first log into it. And here you're going to select, or if it's your very first time using this, you're probably going to have to type it in, that Globus Connect Personal. This would be Pyrenees Desktop for me. And then you're going to use the path text box right here to navigate to the folder on your computer where you want that LIDAR data downloaded to. It doesn't even know right now that you're looking for LIDAR data. We know what we're doing, and we're just getting things set up. The very first part is what's the receiving computer and what is the folder on that computer. Now, by default, nothing is shared for you to write to on your machine. That's part of the initial setup, and it's really simple. In fact, we have more detailed setup instructions available in the step-by-step instructions that are available on our website. And I think you're all going to receive that PDF download as well here following the workshop. Okay, so we got things pretty well set up. Here's our file manager. It's the Pyrenees Desktop, my own machine. And now I have a C drive available to me and a G drive. This is my GIS drive. So I'm going to jump into my GIS drive, go into the data folder, the GIS folder, and my LIDAR folder. And now I start seeing a bunch of stuff on my workstation that's available to me. This is where I'm going to write my LIDAR download to. I'm happy with that. It all looks good. It's pretty simple, nice little interface. If we go down the wrong path, we can go up a folder, so on and so forth. It works out pretty nice. Now we're going to set up the transfer. And to do that, we need to find a server, or the GIS Center server, that has my data. So I'm going to select Transfer or Sync To. That's on the right side of our Globus screen. And then in the Transfer or Sync To text box, which is here, right here, I'm going to type in GIS Trek, all lowercase, just like this, hashtag or pound symbol LIDAR. That is the endpoint name given to our LIDAR server. And then, very similar to what we did on our own desktop, I'm going to browse the folders. Here's that raw folder I was telling you about. Now you'll notice it says raw 2. So okay, that's where your raw data is sitting, and then that's where your processed data is sitting under the processed folder. So you'll select one of these two here, and then just step through it until you find your data. And remember, I was looking for the Bear Lake data. I would go maybe to processed, then I'd go to Eastern, and so on and so forth. Once we find that data, well, I guess before we even go that far, I recommend to people to click on the Transfer and Sync options, which is near the bottom of that Globus page, to provide a descriptive label for the transfer. So you're going to click on this Transfer and Sync options and provide a little label in this Label This Transfer text box. I guess if you're going to download only one LIDAR file ever, then, or for this week or this month or whatever, then it may not be that important. But if you want to grab a bunch of different LIDAR data, and you're going to have all these different transfers happening, and you can have transfers happening simultaneously, I recommend giving it a name. That way you'll see that transfer that you called Bear Lake LIDAR succeeded, and maybe your Bannock County failed for some reason. Otherwise, you're going to just get a number given to you, and it's kind of difficult to figure out what worked and what didn't later on. That's just a tip. You don't have to do that, but that's just a tip I'll throw out there for you for your future file management. Okay, then you're going to download. Select that, dig all the way into it, select the data file that you wish to download. All those large projects, or the largest of the projects, are stored within folders. You can download a whole folder. You can go into a folder and just download a zip file or two, or whatever you want. Once you find what you're looking for, then simply click on the Start. And notice that this Start has an arrow pointing to the left. And what that's doing is it's telling you that you're going to take data from the LIDAR server and download it to your Globus personal workstation, which in the overall picture of it is actually sitting on the left side of your screen in contrast to the server. That's why the arrow points in that direction. So don't get confused about that. It's just trying to help you out. Then I say, go do something else. You do not need to watch those files or the transfer or even keep the page open. You can close the web browser if you wanted to. However, I do like to occasionally check back myself to see its progress, because I'm always curious on what our data transfer speeds are going to be like. I'm looking at performance, network performance, those sort of things. And understand, though, that large files will or may impact network performance for you for other tasks. And Globus is pretty good at saturating your network, filling it up as much as possible to get those data to come through as quickly as possible. So you may see that if you're trying to do other things online, that it's slow. Well, yeah, because this is giant data, very large data. Globus is trying to give it to you as quickly as possible, and your network is going to have some impact because of that big data coming across. The nice thing is, let's say you start this on an evening. Let's say you started that tonight, just before you go home. You started a download. Like I said, you don't have to sit there and watch it. Maybe an hour or two later, based on the file size, maybe 4 hours later, based on the file size, you'll get an email, and it'll tell you that your transfer has completed. You can go into that email, look at overall transfer rates and all that stuff if you like to look at that. Or when you get back into the office, go into your Globus Personal Connect folder that you created on your machine, and there you're going to see the zip file or the folders and zip files that you downloaded, and everything should be right with the world. Now, once complete, remember that LIDAR data zip file, it's just like any other zip file. It's an ordinary zip file. You'll want to extract it. Here's another hint for you. When you extract it, I like to right-click on a zip file. Then you get that flyout, right? And then you're going to do extract to. And I like to choose to extract it to the named folder. So let's say that your zip file is called bearlake.zip. I'll then accept the default extract to bearlake.zip folder. That way, again, it just promotes good file management. I won't have a one folder that's called LIDAR and a whole bunch of LAS files just sitting inside there. You'll never figure them out later on. So do some file management right up front to help you out in the long run. And then simply use your new data, ArcGIS. You can use your LIS files, your Bare Earth TIFF files inside of ArcGIS, and a number of different GIS software as well. Now, I've gone through the material that I wanted to cover with you today. I will open up the floor for any questions that you have. If you don't have any questions at this time, but something comes up later on that you are interested in or need a little help with, you can contact the GIS Center by simply emailing us at giscenter@isu.edu. There's a step-by-step tutorial available from our website. I'm going to go ahead and click on it, and here it is. It goes through even more detail on every one of these little steps to help you get your transfers happening, to get those things completed, to help you out. If you find an error in this, it could be because Globus is constantly updating. We like to try to keep this updated as well as we can. If you find any errors, again, just contact us at giscenter@isu.edu.